Welcome to BCIT Technology Teacher Education 4060. One of our first projects is going to build the front-end hardware for the Scoppy oscilloscope. Scoppy is a neat little open source project that you can get the software for your Android phone or tablet, and this Raspberry Pi Pico W serves as your oscilloscope and sends the data wirelessly to your phone or tablet so that you can use it as a moderately speed oscilloscope. In order to make it work, we're going to have to do some surface mount soldering, and you can see we've got 4 chips on the board that are going to need to be soldered to the board using surface mount techniques. Most of the board is traditional through-hole soldering, but I wanted to make sure not only that you had a chance to do a little bit of surface mount soldering in this class, but also that you were comfortable with it, because surface mount soldering is going to become more and more useful as traditional DIP, dual inline package, through-hole chips that we've used in the past become less available. For instance, I couldn't find some of these chips in a dual inline package, and when I did find them, they cost considerably more than the equivalent surface mount package. Now, this surface mount package that you see right here is an SOIC package, small outline integrated circuit chip. And that's an important choice because it is the biggest of the surface mount chips that you can get typically. And there is a pitch of 50 thou, or what's a regular one's 2.54 millimeters between dual hole pins. So this would be about 1.27 millimeters between these pins. And that's going to make it easier for you and your future students to have success with this. So when you're choosing your chips, choose carefully, because although the SOIC package has big enough chips that we could actually solder that with a soldering iron if we wanted to, take a look at this Raspberry Pi Pico and see all of those little lines right down there. That is a surface mount soldered chip as well, and there's surface mount soldered. So if you spec the wrong size of chip, you could end up getting chips delivered to you like this. And yes, they obviously can be surface mount soldered, but maybe not with your high school students their first time out. So these can definitely be done, and they're done using techniques similar to what I'm going to show you today, but with a little more care and precision than you're going to get the first time you solder chips. Now, if you're soldering, oh, just a minute, look at that, there's my title. It's a scrolling title, and it zooms away. If you're soldering, surface mount soldering for the first time, this is actually a project that I did. This was my first attempt at surface mount soldering, and I didn't order the SOIC chip with the 1.27 millimeter dot pitch. This is half the size, and this has a pin pitch of, I believe, 0.067 or something like that. Very, very tiny between here. And I took this to a tech studies workshop, and pretty much every shop teacher that was there managed to get this soldered and working in the time that we had at the workshop. These are actually little resistors right here. If I can get that close enough, you can actually see a number. I think it's like 102. I think those are 1K resistors, and these are LEDs. And when we turn it on, the microcontroller can flash up on there, blinks everything. And these little pads right here are capacitive touch, so it can tell when I'm touching right on there. So you can definitely go finer than what we're going to do today, and you can definitely do other components. You can get tiny little LEDs, and you can check out the sizes. I think these were like 0207 or something, and when you look out the sizes for surface mount components, you'll see that there's a wide range of sizes and availabilities. Beautiful thing about doing it this way is you don't have to drill any holes to make it work. So that's a really useful thing. Okay, let's get a look at what we're going to be doing today. So I'm going to show you 3 different ways that you can solder SOIC chips onto your Scoppy board. So this is a Scoppy board that I soldered up the other day, and we're going to do all of our surface mount soldering before we do any of the through-hole soldering. And that's just because we want to make sure we get all of this right. And then we're going to double check it and make sure it's all right, because you folks already know how to do most of the through-hole soldering pretty well. So we're just going to make sure this is all right before we proceed. On this one, I've soldered my Raspberry Pi Pico directly to the board. I'm going to recommend against doing that because now I can't use this Pico for anything else. It's kind of neat. This one, the board uses something called castellated pins, which are amenable to both through-hole soldering, because we've got the holes right there, hand soldering, because they're big enough and spaced widely enough that you can get in here and solder that pretty easily by hand, and also surface mount soldering, because the back of the Raspberry Pi Pico is perfectly flat, so you can lay it right down onto the board, put some solder paste in here, and solder it in place the same way that I've soldered these chips into place right here. What I'm going to recommend for your Raspberry Pi Pico, though, is that you mount it on traditional sockets right here, so that if you want to use that Pico for something else, or heaven forbid you damage your Pico, you can just pop that out and replace it with another Pico really quite easily. There we go. Okay. So this is the board you're going to be starting with, and you can see that the part numbers for the chips are written right on the board. You'll also have a handout from me with the specs. Here we have a 74LV4052D. That is these two chips right here, IC4 and IC5. Those are switches that your Raspberry Pi Pico is going to control so that you can get different voltage levels sent to the oscilloscope. You're also going to have these two chips right here, and somewhere on there is the part number for them, IC1 and IC2. Those are op amps, and we're going to talk more about op amps and how they work. They're going to take a very weak signal that comes in from the beginning and amplify it. You'll notice that each of the chips has a little dot in one corner of them. Okay, there's dots right there, and that is your key to orientation. You don't want to put the chip in backwards. Okay, so keep your eye on that dot, pay attention right there, and you'll see a matching dot on the chip when you go to match that up. Okay, so I'm going to show you the first technique right now for soldering this on, and this is a traditional hand soldering technique. You can use hand soldering on chips of this size. I don't really like doing it that way. I think you'll be comfortable with it because you've done it before, but I think you'll find that the solder paste methods that I show you are going to be a lot faster and make you a lot happier with the final result. Your chips are going to come to you in a strip like this, and you can peel back the plastic layer, and you can either drop one out or take a pair of tweezers to gently remove it right there. And thankfully in Vancouver, it's a moist enough environment that we don't have to get too excited about static electricity. And let's see if I can zoom in on that so that you can see the part number on the top right there. There we go. I think that's TLV 9064D. Okay, so the TLV 9064D is your op amp, and you can see right down at this edge right there, there is a little dot on there. So your TLV 9064D is going to fit onto this board right in here. About like so. Okay, yay, it's in place. What we're going to do right now is we're going to see if we can hand solder that into place. Now I'm going to recommend that what we're going to do is we're going to tack one end of it. It's just like doing any welding. So I'm going to take that off right there. I'm going to grab a piece of solder and my soldering iron. And if your solder pads look dirty or anything like that, wipe them down with a little bit of acetone or something. And get ready to go. Make sure that your soldering iron tip is fairly nice and clean and shiny, and apply a little bit of heat there, and then just a little bit of solder. You only want a little pool right on there where working with some pretty fine things. And then bring this in right here. Set your chip on it. Double check that you've got it the right way around and those dots line up. And then when you've got it in there, just apply a little bit of heat to get that pad soft. And as you can see, it's a little bit fidgety. I've got my arm rested on the table. And you might have to play around with that a little bit and make sure that you've got it nice and square. Don't try and move it well. There we go. So now I've been able to hand solder that first connection on there. And look at your board to make sure that it's lying flush to the board, okay? Take a look down there and make sure that's flush onto the board. Then you can come back and you can solder another connection, maybe at the other end of the board, in a traditional technique. Give yourself a little bit of heat, let it get on there, and make sure that the solder has a chance to form a nice little connection right in there. And now we've got two pads joined together on there. And again, it's sitting flush to the board right there. So now we can come over and we can carry on finishing up the other side. Now, if I look really carefully right on there, you can see that I wasn't absolutely perfect at getting this nice and square. This pad is still over top of the, this leg is still over top of the pad right here. So we are going to be able to solder that together. And you can solder that together. And you can go down along here and carefully do one solder joint at a time, apply the heat, and let the solder flow. Now this is a good technique to be aware of, because if you use one of the solder paste techniques and something goes wrong with the thickness of your solder paste, you can come back and you can fix this up with your soldering iron using a fine tip point. Now watch right there. You can see right there I just made a mistake and got a little too much solder on there. If you heat that solder up and pull that away just a little bit, you might have to wipe that tip off a couple of times while you're doing it. That's what your sponge is for right there. Get that heated up and pull that solder away. You don't want any short circuits in between those pins. Now if that's not coming away for you very nicely, grab your solder sucker and get in there with the solder sucker, heat the solder back up so it's liquid, and a couple of pulls with your solder sucker should help you get that out of there. And then just a little reheating on your solder should just make sure that the pads are nicely joined together. Where is that? Right there. Now you can see I've got those ones cleared up. And I'm looking at it really carefully. Now I've got magnifying glasses on each of the benches, and I also have digital microscopes. So you can take a look at this under much higher magnification to make sure that you're getting everything just right as you do it. And this looks like, oh, there's my last one right there on this side. There you go. And just give it enough heat. That solder will naturally flow into the space between the leads and the solder pad. But you just have to give it time to get in there, and you need to be very delicate in the amount of solder that you apply. So this isn't a bad way to do it. It's good for doing little repairs. It's good for fixing things up. And it works okay on the SOIC chip, because the SOIC chip is fairly big with that 1.27 millimeter pitch. If we were to work on something like this chip right here with the 0.6 millimeter pitch, yeah, you can do it in there, but those leads are starting to look pretty big in comparison to these ones right here. So again, choose your chips wisely. But really, this is a time-consuming technique. and you don't want to be doing too much of that. I'm going to show you faster ways to get this done. Once you start down this road, though, you're kind of, well, you're not really stuck with it, because we can move on to the next technique. The next technique is going to be to use some solder paste right here. And this is some Chip Quick SMD rework products. Got this from DigiKey. You can get solder paste at Lee's Electronics too. And this is a leaded solder paste, and it's the No Clean. So the solder paste is kind of cool in that normally when you're using a piece of solder, the solder alloy, the metal of the tin lead mix or your unleaded solder, goes around the outside, and down the very core of your wire you've got a little bit of rosin flux right in there. This one, you actually have a paste where you've got tiny little balls of solder metal embedded in a almost a liquidy, pasty flux material. Now, because I don't use this up all at once, I make sure that I put the cap on nice and tight. I don't want it clogging up. And I also, as you can see, shove a resistor lead down the middle of the syringe right there so that the solder paste comes out. Now, I hold it, let me just zoom out a little bit right here. I hold it kind of like that because you do have to push on it a little bit to get that solder going. And I also grab a couple pieces of paper towel before I begin. I grab the paper towel so I've got something to wipe some excess solder off of. And you'll notice that this is a green size tip. I forget exactly what gauge the green is, but the different color tips are different color codes, and I find that the green works pretty nice for the technique I'm going to show you right now. Now, before you begin, take a piece of that paper that you just picked up, and you want to practice laying a nice thin bead of a continuous strand of solder paste down there. And the faster you go, the thinner it comes out. You want to get just a nice continuous line, and if you need to practice once or twice, about like so is what you're looking for, okay? Because fold that up so that you don't get it everywhere. We're going to throw that out. We don't want lead getting all over our workspace. And what we're going to do right here is we're going to lay down a line of that solder paste right over top of each of our leads. It's going to be one continuous line. I know it seems weird. You don't want it to get too thick, but you can lay it down like so. And you can lay it down like so. And if you don't have a template, like I'm going to show you later on, this actually works out pretty cool. And this is a pretty quick way to do it. Once you're done, take that tip and don't leave it sitting around because it might ooze a bit. Just wipe the tip off and put it onto your paper. Okay, now that is going to be the 74 LV 4052 switch. So I'm going to grab one of those out of its packaging. And you should be able to get it right because I think they have a different number of pins on them than the op-amp did. And get yourself a nice little pair of tweezers so that you can hold that securely. There you go, 74 LV. And this one also, when I rock it back and forth, you can see that dot is flashing in the light right there. Make sure you align your dots, okay? So I'm going to take it down here and I'm just going to rotate it around so that my dot is aligned with this dot right here. And then gently place it. I'm resting my hands on the table here. This is a fine motor operation. Don't try and do this standing up or... And try to press it down as neatly as you can right on top of that solder paste. Now that solder paste looks like it's going to short everything out, but what we're going to do is we're going to heat it up with a heat gun and everything's going to work out okay. So I've put a sacrificial piece of wood under here. Don't heat up your bench, okay? We're not trying to melt your workbench or burn your workbench. We just want to get in here and heat your chip up. And I'm just going to use a generic little heat gun right here. I have a specific heat gun that's really nice and intended for surface mount soldering and rework, but you know, you might not have that around. So I'm going to show you. This works just with a generic heat gun. You just want to be careful that you don't blow everything, all the smithereens. Let's zoom back in right here and get a good view of what we're going to be doing. Oh, nope, that turned it around. Want that. Oh, right. This is what I need to do. I need to move this over here. Okay, so there's the solder paste on there. There's the chip. It's the right chip. It's the right way around. And the leads are all lined up with the pads. Generic heat gun coming in right here. I'm turning it on. Letting it get heated up a little bit. Ooh, warm already. And then I'm going to hold it on here just a little ways off. I don't want to blow the chip away. And keep your eye on that solder. And as the heat gun warms up, the chip's going to warm up. And the solder is going to start warming up. And at some point on here, let me get this in a little closer. At some point you're going to see that solder start to go shiny. You can see it's kind of bubbling there. That's your flux and your rosin starting to heat up and boiling away. It's taking the gun a while to heat up here. It usually goes a bit faster than this, but I'm looking at the screen and I'm looking back here. Distribute the heat around a little bit. You don't want it all in one place at any one point. And when that solder starts to go, it's all going to gravitate to the hot spots. Shininess. Oh, something happened while I was looking at it in person. You can see that that long strand of solder has disappeared and it all got sucked in under those hot little pads, and there's still a little bit of gray right here. I'm just going to see if I can get that gray to go nice and shiny for me. I don't want to burn the board too much. Now, if we're doing this on any kind of more significant process, you know, for a lot of boards or something like that, we'd actually have an oven set up that would heat the solder at just the right temperature and let it all solder in right there. Oh, I'm soldering, heating up the wrong board right there. There we go. And this one you can see nice shiny solders all the way along, and that big long line of solder paste that I put on there has all melted and got sucked in underneath the solder pads. So that's looking pretty good. And so that's method number 2. That's kind of doing a freehand heat gun surface mount solder on there. And when we take a look at that, don't touch the chip itself. That part of the board's going to be hot for a little while. It doesn't look like there's any bridging between the leads, and it looks like there's no gaps in there either, that's down nice and flush and sucked down tidy onto the board. Now where I've got just a little bit of gray left behind right on there, you know, I could come in with my soldering iron and see if I can heat that up. And there you can see I just heated that up and took care of that. Now, anytime you do use these techniques, as I was mentioning, you want to make sure that you don't have any solder bridging, because it is possible that if you've applied too much solder, it could get up and underneath your board. So this is where you're going to use your multimeter And you could get one of the handheld multimeters because they have what I call BP mode, but set your multimeter to ohms mode, and your bench multimeters will flash at you when the probes are not touching, and they will set to, it will show 0 when they are touching. And you can just come down here, and if you want to make sure that these two aren't connected to each other, just touch right there, and you should see your connection flash or show you a high resistance value. Sometimes you might see a high resistance value of like 10k ohms or something like that. That's okay too. And just get in there and compare all of those values to make sure that they're not touching each other. Go through and do them all. You don't want to be troubleshooting your chip after you've soldered everything else into the board, because then the heat gun might end up melting some of your through-hole solders as well. Now, the next thing you also want to check is to make sure that you got this soldered to where it's supposed to go. So sometimes it's easy to see where that goes. And so when I connect from there to there, that's showing me 0 ohms resistance. And when I check from here to here, measuring to that via, I've got 0 ohms resistance. This one you're going to have to check on your paper handouts to see where that one's supposed to connect to. But many of them are pretty easy to check, and those connections are all good. And again, on here, if you've got any doubt as to whether something connects to the other one, if you touch those two probes together like that and you see 0 ohms, that means that you've got a short circuit between them that you have to deal with. There are 1 or 2 exceptions where the pads actually touch each other. So if you get these ones down here, well, of course they're going to show you 0 ohms because these two right here are supposed to be connected to each other. All right, so there is technique 1 with a soldering iron. Technique 2, freehanding it. I'm going to show you technique 3, which is getting a little closer to the mass production style of thing using a solder template. So here's technique 3. I'll call this 3A because when I had these printed circuit boards manufactured, I had the option of ordering a stainless steel template for them. And the template is like 0.012 millimeters thick, which is, and it's got the exact pads that I want cut out right on here. And this is going to let me take this, lay it down on top of the board, and basically just scrape my solder paste on there to do all of my chips at once in one fairly simple operation. Now the pad, the mask might be a little bit messy to start with. Again, you've got that paper towel here. Just make sure everything's nice and clean and tidy, and you don't have anything that's getting in the way before you start. If you need a little bit of help, some isopropyl alcohol or acetone might help you get any stale solder out of there. In fact, I'm just going to give this a little wipe with some acetone to make sure that all the holes are nice and clean and clear. That's looking a little bit tidier, and I can see that the holes are nice and clear right now. Now, I've 3D printed a template right here. It was handy having the board in Fusion 360. I was able to take the dimensions of my template when it arrived, and my dimensions for the board, as well as all of my component locations, were already in there. And I've got that mounted on there, and I did think ahead to leave a hole on the back so that I can pop that out after it's all done. And there's even some little indexing things in there so you can't put it on the wrong way around. I didn't index the template, however, so when you put your template down, make sure that you're putting the solder pads right over top of where you want the solder to go and get that nice and lined up on there. Okay, solder paste mask in place. Now, I don't need as fine a line, so I can actually disconnect the tip. Don't lose that. I'm running low on the green tips, and I can put a little bit of solder paste right across there and put that tip back on so that I don't lose it. Okay, and then take a little scraper and come in here and hold the solder paste mask down in place. Double check to make sure that you're right over top of all of your solder pads. Just scrape that down onto there and make sure that you've got enough solder on there to get it into each of those holes. If you don't have, that should have been about enough solder. Oh, I've got a little bit left on there. Try not to waste the solder. I mean, if you're doing this with a group of other students, then obviously once you're done, then the next student's going to be able to come along and use that as well. And after you've scraped that on there, don't waste that little bit. Let the next person use some of it. There we go. Let's zoom in right here and see if you can see. It looks like the solder has filled up each of those gaps. So now what I'm going to do is I am just going to put my finger in here and I am gently going to lift this off and set it off to the side on a piece of paper towel so I'm not getting solder everywhere. And you should be able to take a look in there and you should have solder right on top of each of those pads. And it should be pretty much perfect. And there you go, in one step you got all of your solder pads covered with solder. That seemed pretty easy, eh? Okay, now once you've got that done, you need to put the right chips onto the right pads in the right places. So let's take a look right here, make sure we've got the right chip. This is the 9064D that I'm going to put on, so that's the op amp. Okay, and the op amp's going to come in there, and you can see the dot on the op amp. So I'm just going to rotate this around. And as gently as possible without smudging the solder pad, I'm going to press that down right into place right there. And there we go, 9064D, and you can see that the dots match up on there. The leads are over top of the appropriate pads, and I'm going to do all 4 chips at the same time this time. So where's this one now? Coming in next. There we go. So this one's going in. Right there. And then I've got my 74LV4052 coming up. And you can see the dots right on there. So rather than turn the chip around, there we go. And you can see the dot matches the dots. I've got the right number of pins. I'm going to place it down right there. And there you've got the chip all in place, ready to go. You can actually pop it out of the, actually you could have popped it out as soon as you had the soldering done, pass that on to the next person so they could put their solder on. And then it's time to bring in our sacrificial piece of wood so that we don't end up damaging our workbench. Set that down there nicely and bring our heat gun back in. And now you've got 4 chips. Now think about this being done industrially. These chips would have all, the mask would have been done by a machine. The chips would have been placed by a robot called a pick and place type machine. And this would then have been run through an oven where they get a preheat and then the correct solder temperature to heat everything in there. And that's how, part of the way, we can make electronics so quickly and so cheaply nowadays. Just keep watching there and you will see, there you go. Oh, that was a nice shot. You can see on that side of the chip. There we go. I should look at it in the real world, not on the camera, but there we go. That all soldered in there super nicely. Some of the heat's starting to get over here. Keep moving that heat around so that it gets in there. Looks like I've got everything on those two chips. Now just think, if you had to drill all those holes, put in the socket, and then press the chip in, you wouldn't get 4 of them done that fast. Now the downside is these are far more difficult than a dip chip in a socket to replace should you burn out the chips. So be nice to your board after you're done, and careful what you do. Okay, there we go. So those are all in place that way, and we've got 4 nicely mounted chips right on there. Everything's still hot, so I'm just picking up the board so that you can get in there and see what it should be looking like. Everything flush to the board, dots in the right way. If you have a problem, we want to fix it at this stage. So take your multimeter leads, and as I was saying earlier, set it to resistance mode and go through and check to make sure that you don't have any connection between your pins. That should keep flashing at you. And just go through and do that here, 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 all the way along. Double check to make sure that they do connect to the places that they are supposed to connect. It should read 0. And if you go through and do all that, then you will save yourself some hassle later on, because we can fix it easily right now. We can come in with the soldering iron and, come in with the heat gun and wipe it all out. So the last method I showed you used a factory-made plate. Now there's other ways you can do that. People have made these using a laser cutter and thin sheets of high-temperature plastics that they can work with. Again, the issue is you want something fairly thin, maybe a bit flexible. I've been experimenting with using my 3D printer. And obviously I use the 3D printer to make the jig for holding the circuit board in place. Well, I've got that on backwards. I added indexing pins so it would only go on one way around. There we go. That sits in there really nicely, holds that firmly and squarely. I just used the model from Fusion 360 Electronics, put a 0.1 millimeter gap around each side and a 0.1 millimeter gap to the edge of the various pins on there. It sits in place beautifully. This has a 0.1 millimeter gap from each of the edges to right on here. A little bit of chamfer in there to help out with things. And then I just transferred the images of all the solder pads, both for the chips and for the Raspberry Pi Pico, onto here, and then printed it out with a very, very fine first layer. So this pad right here is somewhere around 0.012 millimeters, and I couldn't get my 3D printer. I've got a Bamboo P1S, works beautifully, high quality finish. I couldn't get it to print 2 layers at 0.06 reliably. So I went a little bit thicker on here. I set my first layer to 0.08. And even at 0.08 millimeters, I had to slow the print head down to about half speed to get that layer to stick reliably. And then I used a 0.08 layer height for the rest of my printing, so that this layer right here that we're going to use as our mask is 0.016 millimeters thick. Okay, so now this can fit down right over top of here, and the two are indexed together so that if I put them on the right way around, I want to double check, and why are those not lining up? There we go. always double check. I didn't put indexing onto here. I put indexing onto here, but not onto here. Don't ask why. I'm still experimenting with this technique. But this fits down right onto there. And now you can see that the plastic layer is serving as a nice little mask and lines up really nicely with the pads that I've got underneath there. So I can use this for doing my solder paste layout. This one I'm going to solder the Raspberry Pi Pico directly to the board. Again, I don't recommend that you do that because you might want to take your Pi out, your Pico out and use it for something else later on. You might damage the Pico, but I'm going to do it here just because that's the way I designed this. So I'm going to zoom out a little bit so you can see what I'm doing at a bigger scale here. Okay, and this works out pretty much the same way. You can take the little syringe top off right here and give yourself a little bit of solder paste to work with. Oh gosh, that's probably more than enough. Now again, I forgot to mention earlier, the solder paste works so much better when it's warmed up. I usually keep it in my fridge because that just keeps the flux in better shape. But yeah, this works so much better when it's warmed up. Don't take it right out of the fridge and try to use it. There we go. That's getting mashed in there. Now this is stepping up a little bit more than it did the other day, so I'm going to be interested to see how that works out. I think I've stretched that top layer, something that doesn't happen with the stainless steel quite the same way. See if I can get that all in there nicely. And generally I'm looking for my pads to look gray rather than shiny. I want to make sure that they've got, there we go. Again, putting my scraper somewhere where I'm not going to get solder paste absolutely everywhere. And then I'm going to pop that lid off of there. And now that's come up off of there. I had a little problem printing right down in there, so there might be a little slop in one corner that needs cleaning up. Put that somewhere where I don't get solder paste everywhere. And then I can pop my board out and take a little closer look at how that came out. And that's looking pretty good. There should be about 0.16 millimeters of solder on each of those pads. Now down here, you can see I've got just a little bit of a problem in that corner between VSys, VBus, and ground. Those are like the last 3 pins that you ever want to be connected together on your Raspberry Pi Pico. That's just guaranteed short out if those ones are connected together. So what I'm going to do is I'm going to clean that off, and then just for those 3 pads, apply a little bit by hand. There we go. A little bit of paper towel. Make sure the paper towel ends up going off to the garbage. And then with that nice little green tip right back on there, put a little dab right there, a little dab right there. Of course, we could have done that for each of those pads, but you know, I don't know, 40 pads like that, I think scraping it on through a mask probably went easier. Okay, I'm going to put the chips on there and solder them up, but you've already seen that, so it's going to look pretty much the same to things that you've already seen. Now, it's the end of the day, and at the end of the day, it's time to put our solder paste away. Okay, so when it comes time to put the solder paste away, this syringe tube can end up getting jammed up pretty bad. And it happens to be just the right size that if you very carefully take a resistor, you can slide that resistor down there. Oh, and that resistor will force all of the solder back down into the syringe, and that resistor lead, when you pull it out next day, should come out nice and smoothly. And then I cover it up with a cap right there so that it's not likely to dry out anyway. And now your solder paste should be fresh and ready to go. And as you can see, we almost used no solder paste whatsoever today. Then just to double check and make sure nothing dries out, we take this all, put it back into its nicely labeled bag so that we can seal it up nice and tight in there. And if I was putting it away for a long time, I'd put it in the fridge. Okay, I'm going to add some chips to that and solder it up. But you've seen the technique, and now you know how to get your chips on here with hand soldering, with hand application of solder paste and a heat gun, and using a mask, either a stainless steel mask or my experimental 3D printed masks, to get in there and apply your solder and then heat them up with a heat gun. Surface mount chips, the SOIC chip, small outline integrated circuit, with a pitch, the space between pins, of 1.27 millimeters, is pretty easy to do, and I think faster and more efficient than soldering through-hole dip parts, particularly when you're doing it at scale or for mass production. The catch is a little harder to fix than when you're doing it with scale or dip parts, and because you have to heat the whole thing up and remove it. You can't just pop it out of a socket. There are, of course, surface mounted sockets, but anyway, then you start to lose some of the wonders of doing it this way. You can go smaller. As you can see right on here, we went down to a 0.67 millimeter pad pitch, and I think that was TSOP, a TSOP size chip. If you look up surface mount technology, SMT pad outline, you can see the outlines and the spacing for all the different chip types. And you can also find out the sizes and spacing for the various components like resistors and LEDs. So you can make an entire board using surface mount technique. Or like on this one, you can use a combination of surface mount and through hole right here. Okay, folks, thank you very much. There you go. Surface mount soldering for TTED 4060 and your Scoppy project.